Hey everybody, so we're going to kick off in about 2 minutes. We're just going to wait for a couple more attendees to jump in, so we'll probably kick off at about 2 minutes past the hour. Thanks everybody for joining in. Hey everybody, thanks for joining us today. My name is Dean and I'm going to be your host for this webinar. So today we're going to talk to Richard Rodger, CTO and co-founder of nearForm, about his new book, The Tao of Microservices. Richard is a member and influencer in both microservice and Node.js circles and is the creator of Seneca.js, a microservices toolkit for Node.js. He's previously the CTO of Feed Henry, a mobile application platform provider that was acquired by Red Hat for $63.5 million in 2014. So before I introduce Richard and before we kick off, I want to do some quick housekeeping. We're going to run for about 50-ish minutes, and we have, myself and Richard have come up with some what we feel are interesting topics to talk about for the first 30 minutes, and then we'd like to keep it fluid, so we've allocated kind of 10 to 15 minutes for user questions. So if you pop the questions into the chat, we can get the little elves to get them onto us, and hopefully we can get some interesting banter going. We also have a discount code for everybody at the end of this, so you'll be able to get 36%, I believe, off Richard's book, so definitely stay tuned for that. Okay, Richard, thanks for taking the time to be here. Welcome to the show.
Hey, Dean, thank you very much. What a fantastic intro. Thank you very much. I'm extremely flattered.
I thought you'd like that, all right. I said we'd go ahead and make it sound much better than you are.
I didn't expect you to be kind, but you were.
I was. I like to be kind. I like to get you when you're off guard, so keep an eye out. Okay, do you want to jump into? Shall we jump straight into the questions, because we've got a lot of really interesting things to cover.
Let's do it.
Awesome. Okay, so first off, congratulations on your release for the first 2 chapters of your book. Most people who work in the software industry will have heard of microservices by now. Some love it, some hate it. What's the big attraction for you?
I guess it's microservices are kind of about facing the truth, the reality of software development. You know, that things are always going to fail. They're always going to be broken. So instead of trying to write perfect software, let's embrace that. So I prepared a couple of slides, you know, And this particular one here is this is called kintsugi, which stands for golden joinery in Japanese. And the story behind this particular art form is that 15th century shogun had this beautiful bowl, tea ceremony bowl, and dropped it and it broke, and he sent it back to China to be repaired. And the repairs were done with kind of gold studs, but it didn't look very nice. It was not very aesthetic. So he challenged his Japanese craftsmen to come up with a better way. And the way they came up with was this golden joinery, where you take gold dust and putty and you reassemble the bowl. And so the thing that was broken suddenly becomes whole again. And it's a philosophy of embracing failures. So Adrian Cockcroft is a really good metaphor for this as well. Microservices are, you've heard microservices, they aren't pets. Each individual service is individually irrelevant and can die. It's the totality of the services that makes sense.
Awesome. Yeah, no, I fully agree myself, and I have to say I've been doing some microservices myself, of course, and I find that when you accept this sort of failure, absolutely, it just becomes much easier to build microservices when you accept that you're never going to get it right first time.
I mean, it's really an extension of a principle that I learned a long time ago, especially when I was running, Java JVMs in production, which is that JVMs always have memory leaks. They really always do. It doesn't matter what you do, right?
Yeah.
And each iteration might introduce a new one. So, best practice is you restart them every X number of hours anyway. And of course, you have your load balancer set up to do that. So, even in the monolithic world, you're kind of forced to accept failures. In the microservice world, it just becomes a natural part of the system. You don't need a chaos monkey because, you know what, your services, the microservices themselves, will kill themselves after a while, in any case. And it means that, things like memory leaks actually become part of the fabric of your app, as opposed to being something that you need to spend days or weeks trying to fix. And you can direct energy towards business features where the money is made.
Absolutely, and this ties in nicely to my next question. So I'm going to embarrass you a little bit, and I'm going to bring up a little quote I found on your blog, which was that microservices put the fun back into building software. I like that quote. Can you tell me a bit more about it, or a bit more about how you feel that the fun comes back to software by doing microservices?
Well, if you think about the unfun side of things, when you're working in a large team and you're working on a monolith and you have, release cycle, and you might only be producing a new version every 3 months. I mean, this is the world of enterprise software. And even then, you might have developers on one side and this QA, and then there's the IT department, and everybody's fighting each other, and it's just a really, really slow process. And to get anything done, takes weeks and weeks. But the fun of software, and when you first started learning to code, I learned to code on a ZX Spectrum, basic. Back in the day.
Very good. Very good.
The immediacy of it was brilliant, right? It was really good, right? And the reason I had to learn to code was my parents forgot to buy any games, so there was nothing to do. You had to program. If you wanted a game, you had to write it yourself. So the immediacy of the feedback is the cool thing about microservices, because if you need a new feature, write a new microservice, deploy it into production, and put 1% of the traffic through it and see, does it work? Does it break anything? Does it improve the metrics? And you can literally do that day by day. And that's fantastically empowering, because you can actually see that you're having an effect on the business. And again, the slide that I've chosen for this particular question is kind of evocative of that. It's a picture of an airplane called the Gossamer Albatross, which is pedal powered. And it was the first human-powered airplane to cross the English Channel. The story behind it is that a wealthy industrialist created this kind of X Prize, where he said, there's this £100,000 sterling for the first person to cross the English Channel. And 10 years later, nobody had. Lots of teams that tried, and they were, they carefully designed their airplanes, spent a year building them, and then somebody would get in and either collapse from exhaustion after 200 yards, or the thing, wasn't airworthy. the guy who eventually managed to build an airplane that could cross the English Channel under pedal power, a guy called Paul Kramer, realized that the problem wasn't crossing the English Channel. The problem was building airplanes. And he came up with a set of components, mylar and aluminum piping and wiring, that let him build lots and lots of different airplanes, sometimes 3 different airplanes a day, so that he could iterate really, really fast. And within the year, he had solved the problem. So iteration and feedback are so essential to problem solving. When our software systems prevent us from getting fast feedback, it's actually exponentially worse than you think. And the great thing about microservices is fast feedback, and fast feedback is really enjoyable, and that's where the fun comes from.
And it's quite interesting because we've taken on a couple of interns on the project I'm working on, and the thing that surprised me most about it was this is my first big microservices project. I suppose what I found was the interns seemed to be more naturally at home with microservices, because when we cut out all of the cruft, and when it was literally down to just, make a change, push it, see does it work, stop, make a change, push, see does it work, they were able to come up with features that your average intern on a standard a monolithic application just wouldn't have been able to do. So I can definitely understand the whole fun side of it. It's one of these things, I suppose, where until you've lived it, or until you've played with microservices, you can't really kind of feel.
And that's not to say you're right, Dean. And that's not to say that microservices don't have downsides. No. You've got to do other stuff to make them work. But the fun quotient is much higher.
Yes, absolutely. And that's so one of the kind of the feedback into this is I was reading through the book. And one of the parts I noticed was you're saying that it's a field report from the front lines of microservice architecture. And this is interesting because right now a lot of the things myself and my team are playing with haven't gone live just yet in a customer sense. But a lot of the work you've done has gone live. So can you tell us a little bit about some of the projects and some actual live microservice architectures you work on? What difference did it make in those projects?
So here's a project. Here's one of the projects that we put live for a customer last year, and I'll just go over the challenges in this project. So this was a complete rebuild of the London School of Marketing's content and learning platform, which is an extremely complex platform where students have to go through a series of modules and they get tested, and then on the other side, lecturers and content providers upload material, structure it. So extremely complex CMS with a whole bunch of other workflows and interactions, and a really nasty deadline, because the start of term is the start of term, and you expect to start learning on day 1. And there really is no way out of it. The whole thing has to work. So they had an older system, which was a PHP monolith, which they wanted to rebuild. And the reason they came to us, to nearForm, was not because they bought into technology, and we rebuilt the thing using Node.js, but it was because they wanted to be empowered to move forward quickly themselves. They were looking at Netflix and Uber and companies like that and saying, we're a technology company, really. Yeah, software is eating the world, as Mark Andreessen, formerly of Netscape, has said. And the ability to do that comes not from project management processes or unit testing or anything like that. Really, the ability to do it comes from structuring your software in the right way. And that's where microservices come in. And just to give you an idea of the challenge, you can see I've kind of written it down here. So there was a 12-week deadline. This was over 3 companies. So London School of Marketing themselves, ourselves, and another outsourcing company in the Ukraine. The development team was spread over 6 countries, over 10.5 time zone hours. So there was a guy in Jamaica also working on this. So from Jamaica to Ukraine, right? 9 developers in total. 6 of them had not built any Node.js code before. 5 of them had never met, not even virtually. 3 of them were new hires, and 3 of them spoke no English. So this project, now, would you sign up for this project? Would you, Dean, would you take this on?
Honestly, I didn't know. And I'd like to drill down into this a little bit, because the reality I find of microservices is when I hear people speak about them, it's always on nice greenfield projects. But the reality of this project is it's really dirty and icky, and it's real world. You know, these are the sort of deadlines I've had to do before. These are the sort of silly things where we've had to onboard people, and they've never used either the new language that we're using or the specific set of toolkits. So I'm interested to figure out how did it go on from a kind of a day-to-day perspective. How did you find that they got into the microservice way of doing things? Because it is different. It is different than how you do monoliths. You kind of have to change your brain a little bit.
Absolutely, and this project is interesting in the sense that it was, even though it was ultimately deployed as monoliths, as microservices, it was actually built using a monolith-first approach. So there's this big question in the microservice world of over, do you start with microservices, or do you start with a monolith and then break it apart? And in some ways, that question is a false question. Because if you abstract the way that microservices communicate, then you can start with a monolith and then you can break it apart. Because as far as the individual microservices are concerned, it doesn't really matter if they're running in the same process or not. We took a relatively conservative approach with this project, even though we had identified a couple of hundred different messages, and out of that, a couple of tens of services. The system itself ultimately runs with, I think, 6 or 7 individual types of process, each one containing 5 to 10 microservices in the abstract. So I described this one as a hybrid. Nonetheless, we still got the key benefits from the microservice approach, which is the fact that you have lots of people working in parallel. You can do very dynamic deployments and updates. You can package tasks for individual developers down to very simple world. These are the messages that are coming into your service. These are the messages that are going out. And here's the little bit of business logic that you need to implement. And even the data store is represented by messages. So that means that an individual developer can mock up all the rest of the world. They don't need to have the whole system. They just need to build the messages in, the messages out to spec. And it gives you a very, very fast way to build things in parallel. I suppose on the process side, we don't tend to use processes too heavy, but it gave us the ability to continuously demo the work at least once a week, if not more so, which gives you again this really fast feedback cycle and feedback from the client as well.
So that's, and I really want to kind of hammer home that point. That's super interesting when you said it's a false question about whether you should choose a monolith first or whether you should just go full-blown microservices. Because in my experience, I fully agree. It is a false question for the simple fact that you're going to hamstring yourself, because in certain cases, what I've found anyway, as I've been playing around, is sometimes a system is so small that it just doesn't make sense to deploy it as a set of microservices. But if you build your system in a certain way, the single process in and of itself is a set of microservices. It's just that the unit of deployment has changed, right?
Exactly. And I mean, yeah, and this goes into the question of what is the essence of microservices, and it's actually not the way that they're deployed or the fact that you have to have a ton more automation. I mean, you see a lot of people criticizing microservices by going, oh, you have to do all this work before you can even get started. To which I reply, well, why aren't you automating your deployments anyway? This is not exactly, this is not exactly a thing that's new. I mean, okay, if you're planning to run up to hundreds of services, then you're going to be looking at things like Kubernetes, or maybe if your system is a bit different, Docker Swarm or something like that. But these days, if you're not thinking automation from day one, I mean, this is like having a build server from day one. It's just, this is software engineering, guys.
Yes, software 101. Absolutely. So we've been touching on a couple of really interesting things there, and I do want to say to the audience, if you've got any questions, especially about what we're talking about so far, absolutely send them on in, and we'll make some time at the end for them, because we're going to touch on things super high level. So yeah, I want to jump into the next question, which kind of ties in nicely again. This is around technical debt. So that big old nasty word. And before I ask the question, I want to quickly say my feeling on technical debt, which is I don't like the word. I feel it's very loaded. I feel that the problem is that it's said as if it's a bad thing. But for me, maybe it's a bit more of a nuanced experience. But I found that you can totally use technical debt to your advantage. But let me jump into my question for you, which is, you know, microservice architectures can help developers and architects pay off technical debt later on. Have you any thoughts on technical debt, or what's your feelings around it? Because it is a touchy subject right now.
So it's important to understand technical debt from a software engineering perspective, because every single project, microservice monolith, whatever it is going to have technical debt, and that is what it is. Essentially is you've created this logical model of the world, and then the world changes, and your logical model doesn't fit anymore, and it's really, really expensive to recreate a new logical model. So you start changing and twisting and turning the model, the original model, and you end up with SQL Server databases that have 200 tables, and each table has 30 fields, and some of them aren't used, and all sorts of crazy stuff like that. Or your code base, you know, you come up, you have a nice UML diagram at the start, but then it all sort of collapses.
Yeah.
And people use things like, you know, they try to use unit testing and refactoring and things like dependency injection and a whole bunch of different ways to fight this technical debt. The technical debt is really evil. Dean, have you seen the movie Gravity?
I have. It's quite an awesome movie, I have to say.
It's an awesome movie, and it's a great example of how technical debt actually works in practice. So the film Gravity is kind of a fictional version of something called the Kessler syndrome, which is basically if enough satellites in space crash into each other in low Earth orbit, there'll be enough debris, little pieces of metal flying around that it'll create a cascading effect where basically all the satellites take each other out, and you have this swarm. You can see here in the image. This is actually the NASA. This is all the known bits of space debris at the moment that NASA's tracking, like several thousand. But once these things go out of control, you basically can't launch rockets anymore. And that is almost an exact metaphor for what happens in software projects when technical debt overwhelms the architectural and abstract structure of the system. It becomes very hard to make changes, and every change affects loads of other things, and the cost of adding new features goes way up. And this is part of the underlying problem. Part of the drive towards microservices is the ability to keep making changes and keep adding new features without incurring too much technical debt. And the way microservices do that is, well, new feature, new microservice, so you're not really affecting the rest of the system. And if a microservice itself starts becoming too big, well, that's a warning sign, because you know they're microservices, so you get an immediate measure of the fact that you're adding too much complexity.
So I have a lovely little name for them. I call them little balls of mud. Because as long as the inside of it, or as long as the outside of it looks pretty, I'm pretty much happy to leave the inside rot for all I care. I have found that if you, and I fully agree in terms of splitting them down, if you aggressively split them down into small little bits, the problem I find of technical debt, as I said, it can be used to your advantage, because you can get a forced pass out. I mean, I can do a forced pass of most standard kind of software functionality that people are looking to buy. I can do it in about a week, and that's literally just by hitting a force pass force, wrapping it all up into a nice little microservice, and not worrying about the overall impact on the system, because there is no overall impact on the system.
So the nice thing, the thing that really makes that work are kind of two of the key principles of microservices, which I mean, the whole microservice world is we're still in a research phase. We're still kind of figuring out best practices, that sort of stuff. But two that I would really recommend are a principle called transport independence and another principle called pattern matching. So transport independence kind of takes us back to the idea that you could be monolith first or microservice first. The transport mechanism, the way the messages go from one microservice to another, should not matter, right? It might be HTTP, it might be RabbitMQ, it might be a function call. It just doesn't matter. From the perspective of the microservice, it's just messages in, messages out. So fixating on REST and that sort of stuff as being the essence of microservices, I think misses the point. The transport should be independent.
It's funny, I'm smiling for myself. We had a technical review the other week with a client, and he was asking me what database we were using, and I said I haven't made that decision yet. And he said, well, how are you storing the data? And I was like, oh well, it turns out that the bit of tooling we used supports fake data. Essentially, you can give it data, and as long as the thing is running in memory, it will store the data as if it's got a database behind it. And it feeds into this. It's just a case of maybe kicking those decisions down the road or just not caring about them. I do love that sort of experiments.
No, it does mean you can. It doesn't mean you can do that sort of thing. But I'll just jump in there, Dean, and talk about pattern matching as well. If you don't mind.
I'm a big fan.
So the thing about pattern matching is that it allows you to move from the general to the specific very easily. So if you imagine I emit a message, let's say it's a user login message. At the very start of my system, there might be only one type of user. So there's one microservice that handles user logins. But as I add more different types of users, I might have employees and contractors and visitors and customers and whatever. I can start adding new microservices that deal with specific types of users. So I don't have a general user login message anymore. I have a specific one. My specific messages can be captured by specific microservices. So the microservice that handles the logins for, let's say, employees recognizes employee login messages, independent of all the other ones. So the microservices have no knowledge of each other, and they have no knowledge of the categorization of the messages. They're just doing simplistic pattern matching on the universe of messages. Now, the implementation of that is something that, obviously you need to work it out. You can't look. In reality, every service can't look at every message, but there's ways and means of doing that. That's just an engineering problem. The basic principle is services look at all the messages, or we pretend that they look at all the messages, and they just take in the ones they care about.
So on that quickly, we got a user question in actually. It's crazy how quickly pattern matching causes questions. So the question is, should patterns be specific to a microservice? Is there a one-to-one between them?
No, and this kind of goes back. This kind of goes back to the idea of how you design microservice systems from the top. So generally, the way we approach it is to understand the business requirements. And that then feeds into things that happen, actions in the system. And each action is essentially a message or a set of messages. And then you have a list of these messages, which is essentially a domain language. And then each message is represented by a pattern. So what are the attributes of the message that matter? And once you have this message language, you can group your messages into sensible groups, like everything to do with users, or everything to do with checkout, or everything to do with the database. And that gives you a very very sensible way of deciding what the microservices will be. So in general, each microservice deals with 5 to 10 different patterns. But I mean, it could be as many as 100 if there's some sort of structure to them. And in some cases, yes, you do have microservices that only handle one pattern.
Yeah, so we got a bit of a burnout on this, or we had to do a bit of rework because we were being quite aggressive in that a specific set of patterns would only talk to a specific microservice, and it turns out that the world is grey, and that's not how it works at all. And what we found was instead of focusing on this microservice does these patterns, it was give me all of the pattern groups. And then, most of the time they will fit neatly into a microservice, but we did have a couple of microservices which would, I suppose, they would use patterns from other microservices. And it was just the way the whole thing meshed naturally. But once we kind of got rid of the hard rule of this pattern must belong to this microservice, and we loosened it up a bit, we found great we found great improvements. And it was just, as you said, it was a case of grouping them together as patterns and not worrying so much about the service itself or worrying about what the service should do, and really focusing against the patterns.
Absolutely, and it's something that you kind of need to experience it to feel it. It feels like it shouldn't be powerful enough, but it's kind of weird. It's very simple, but it's just powerful enough to build really complex systems.
I've been pretty amazed by how complex you can get. I'm a big believer now in pattern matching. I wasn't at the start, but I'm a big believer now. And I think regardless of the language you use, I think you should always look towards doing pattern matching. So I want to jump on to our next question, because I'm hoping you've read this. I don't know if you've seen an article by a gentleman called David Boyk, and it's called "Microservices: The Future or Empty Hype." And basically, yes. Very good. So basically, the author is going through. I'll list them out for the audience. He's saying that there's problems that microservices cannot solve. You've got incorrect requirements, weak processes, bad habits. So I'm gonna keep my feelings back. What are your feelings on that article?
So I think there's a lot of articles, and I think that is one of them, where you have someone who has a lot of experience in the software industry, a genuine experience and completely valid experience, but who is perhaps misapplying their experiences to a new style of architecture. It's often the case that you have to try something to really understand how it works, and that's a significant investment. I mean, unless you've actually gone out and built something like the London School of Marketing, you don't really understand the downsides to microservices. And yes, absolutely there are. There are downsides. I mean, if you've ever constructed a self-reinforcing message loop that keeps on generating more and more messages, you learn pretty quickly that you're going to need things like kill switches and correlation IDs and all that sort of stuff. So the primary benefit that we're after here with microservices is the ability to react quickly to changing business requirements. And we are sacrificing some of the nicer aspects of traditional software engineering, like schemas and structure and the ability to validate things fully with unit tests and that sort of stuff. So it is absolutely a trade-off. So in one sense, yes, everything he says is correct. But in another sense, you have to say, and what does that buy you? What is the benefit? So I have a picture here of the monolith from 2001: A Space Odyssey. And because, hey, monoliths, right? Here's the thing. Monoliths also have a set of disadvantages and a set of advantages. And I could write an essay, and I have actually written essays hammering monoliths in the same way. At the end of the day, if you are a software developer, if you're an architect, you have to look at the needs of your client, and you have to say, okay, this particular application, let's say it's an autopilot system for an airplane, very strict requirements, very well defined, not going to change rapidly. Yeah, it's probably a monolith. Versus we're launching a new e-commerce website in the fashion industry, and we have a whole bunch of other unicorn competitors, and we need to react day by day to everything that's happening and add new features and social media sites and whatever. In that case, you know what? On a day when 1% of users can't log in because you broke something, maybe the business can live with that, because you need to move fast.
Absolutely, and it's interesting. So microservices are no panacea, essentially. I do find that there is an over reliance on people as well to kind of say microservices are the future and the only future. And it's interesting that you brought up technology that needs to go into things like airplanes and things like this. I mean, it absolutely needs to be a monolith in that case.
There is another aspect to this, and I will argue the case that microservices are a step forward all the same. And the case that I would make for that is that they are good component architecture. So object-oriented programming was meant to be a good component architecture.
But we never did that right. You know, we never
No,
did have recurring account, right?
and the proof that it didn't work is the Gang of Four design book, right? Because here you have your language and all the things that you can do, like polymorphism and inheritance, etc. And then it turns out that there's a whole other set of things you have to learn to do it right. Microservices are so simple in that. Well, here's an example. Let's say I have a little business logic service talking to a data service that's fronting a database, and everything is going along nicely until the system comes under higher load, and I now need to cache database results. Now, in a monolith, you have to think about, you know, does that go above or below your ORM, and what's your abstraction layer, and all that sort of stuff. In the microservice world, you just add a caching microservice in between the business logic and the data. And from the business logic perspective, nothing has changed. The same messages are going in and out. And from the data perspective, it's the same as well, right? Except there's fewer messages now because the cache is only talking to the database every so often. So you have this ability to add components and to compose together features in a very easy way without requiring underlying changes and without pre-designing that architecture. You know, a very simple example of a component architecture is the Unix pipes and Unix command line tools. And it's based on the fact that, exactly, and they're very powerful because it's based on a simple model, which is just streams of text. Microservice messages are also a really simple model. So you have this world where instead of having, you know, properties of objects and virtual methods or class methods or whatever, if you look at traditional object-oriented languages, there's like 20 different ways to interact with an object. With a microservice, there's only one way. Just send it a message.
Yeah, agreed. And I really do wish we could talk more and more, but I do want to jump into audience questions, and I do want to just give just another quick shout out and say that if you have any questions, pop them in chat and we'll get them read out. So I got a couple of questions. Or do I have any more? Let me think.
Just before you do, Gene, the last slide here is just if you want to see microservices in action, you want to see actual source code. This NodeZoo system, which is a little search engine for node modules, is a good place to see it. And you can actually see it's open source, and it shows you a small-ish microservice system and how it interacts. It's all Node.js, which means it's JavaScript, which means everybody can understand it. Even if you hate Node, it's still a great way to see a microservice system put together.
And I believe it's all being reworked into all the brand new technologies, React, Webpack. I've seen a lot of
exactly.
From it. Lovely. So let's jump into audience questions. The first one, I suppose, is the most obvious. It's where do you think microservice architectures will be in 5 years? Sorry, where do you think microservice architectures will be in 5 years?
Oh, I think they'll be the de facto standard for most enterprise software development. In the same way that, you know, everybody does unit testing now. You know, everybody does OO. You know, that's why I say that they do have some advantages over monoliths. And look, we're crawling out of the mud here, right? We're evolving, and we're still on the beach. And we've just grown. One of our flippers has just grown a toe. And that's microservices, but we're not out of the water yet.
No, I agree, and I think we do have some issues. Even from my own experience, there's still bits that have rough edges on them. Absolutely. So let me see. We've got some more. So you say you've been working with microservices since 2011. That's good years. How did you first come across them? What form did it take back then?
So in mid-2011, I took on this really crazy high-intensity project to rebuild the Sunday Business Post, which is Ireland's kind of national business newspaper, in 3 months. And when I say rebuild, I mean the web apps, the mobile apps, the tablet apps, the website, payment systems, both iTunes and credit card, and an integration with the stock tracking system. So it was all a bit crazy. I eventually had to bring in one or two other people to help me, and we ended up using Node, and we ended up using a system based on messages with Redis as the kind of message transport, all cobbled together, hand-crafted, hand-coded. But because we were all working in different locations, I was freelancing at the time. you know, it was very hard to coordinate, and I couldn't manage the project because I was coding, you know, 18 hours a day to try and get this thing ready. And this message-based system where you could, you know, allocate the work in parallel just worked really, really nicely. And also in production, it meant that we had a very stable system. That website was only taken out. There was a lightning strike on one of the Amazon data centers back in 2012. It took us out for a couple of hours. But apart from that, I mean, it worked really well. We were doing manual deployments though, right? Manual microservice deployments. What fun!
I'd say that.
So I won't do that again.
No, I'd say that. So it's interesting. So that's kind of microservices because you had no other choice, essentially. I don't think you would have got as far as you did with a monolith. Certainly not that volume. In that volume of time. So we got a fan. We got somebody with one of your old books, mobile application development in the cloud, which I've read. It's quite good. So one of the first dedicated works to deal with Node.js. Is there a logical connection between both books? So this and the Tao of Microservices.
Yeah, I guess the connection is Node.js because, well, here's the truth. You know, JavaScript as a language does not scale. You can't write large code bases in JavaScript. It doesn't have enough structure and power.
I think this is probably the first problems that Node started to face, right? When it became popular was this issue.
Yeah, exactly. So structuring the applications, and I mean, this is why a lot of people who have a lot of experience with other languages sort of go, JavaScript, really? So you're sort of forced to say, okay, well, the language is so weak. Is there another way to build large systems? And well, one obvious way is break everything apart into small pieces, so that you never actually have to write more than you know, you never actually have to write you know, 10,000 lines of JavaScript in one system. You just don't do that because that is not the way. The way is microservices.
Absolutely. Okay, so look, our time is nearly up, and I have to say I'm pretty delighted we got more. I wish we could have set this for 2 hours. You always, you know, it always ends up.
Oh yeah.
So hopefully we'll bring you back and maybe do another one.
Absolutely.
So, yeah. So listen, I want to.
Well, here's a few links anyway. So I asked the publisher if they would do a deal of the day on the book.
Awesome.
And they kindly agreed. So the Tao of Microservices is deal of the day, I think, for another 10 hours, which means it's I think it's 33% off.
26.
The first chapter is free, and very good. 36. Yeah. The first chapter is free in any case, and there's a lot more chapters to come.
Awesome. So let me do a quick recap on the book. So the book is called The Tao of Microservices. It's published by Manning. The full book is due for publication in fall this year, but the first 2 chapters are available already on early release. So we have the link up on screen. And Richard has already said that we've got a nice little discount, so we're pretty happy with that. So listen, thanks everybody for tuning in. I'm sorry it wasn't longer. I always find these things go much quicker than but you can absolutely catch Richard and myself on Twitter, nattering back and forth.
Absolutely.
And if you have any feedback as well, we'd love to hear it. I think we'd like to do this again and maybe bring in some of our more controversial friends and family who have done microservices. And there's definitely a lot to talk about here. And I just want to say as well, thanks to nearForm for hosting this there at nearForm. And if you want to check out their blog NodeCrunch, they'll have details on future webinars coming up. So I think that's
thank you very much.
Thanks a million.
Thank you. All right. Bye-bye.
Bye-bye.